And I want to look back at number 2 because we did number 2 yesterday using the product rule at the end of class. I want to stress to you that on a problem like number 2, you don't have to use the product rule. We use the product rule because I'm teaching you product rule and I want an example where we could use product rule. But when you see this, you don't have to use the product rule. Your other option for doing this is to just distribute here. So you'd get 15x plus 12x squared minus 10x squared minus 8x to the third. And so you would be doing the derivative of 15x plus 2x squared minus 8x to the third. And that would be 15 plus 4x minus 24x squared, which hopefully is what we got yesterday, right? So I really honestly think it's probably easier to do it this way than to use the product rule. So either one of those are options. However, there are problems where there is no option. You can't do it other way. So let's look at another one of those. So here's a new example. So this will be number 3. So if you'll add these to those notes we were taking, oh, no, we weren't taking them on paper. I printed them down. All right, it's already there. Sorry, I've been making pre-cal write their notes a little bit, and I was getting mixed up. All right, so for this, part of this function requires product rule. Part of it does not. Okay, this first part requires you to use the product rule because you have 3x times sine x. So this expression right here, 3x, that is a function. It includes a variable. So you're going to have to use the product rule for 3x times sine x. However, over here, you've got 2 times sine x. This is not a problem that requires the product rule. Technically, you could use it. But you'd probably mess it up if you did. But 2 is just a coefficient. There's no variable with it. So when we just have coefficients, the properties of derivatives just tell us we can basically just keep the coefficient there and take the derivative of the other part, right? So, but if you have 2 things multiplied and both of those pieces include x's, you're going to have to use the product rule. And there is no option of like distributing and expanding here, so we don't have to use the product rule because we got that sine x. So we can't do like I just did on number 2 as another option. So let's remember from yesterday the product rule. I'm going to write it down again just so I've got it right here on the screen, but you don't necessarily have to because you can see it there. If I'm taking the derivative of f of x times g of x, that is going to be f of x times g prime of x plus g of x times f prime of x. Okay, so f g prime g f prime. So in this case, we're going to let that 3x be our f. We're going to let the sine x be our g. So when we take this derivative here, we are going to have f, which is just our 3x, times the derivative of g. Paul, what is the derivative of sine x? Cosine x. So we'll have cosine x here. So that's our f times g prime plus g. just the g, not doing anything to it, just the sin x, times f prime. Wesley, what's the derivative of 3x?
3.
Just 3. All right. Now, be careful here, because you're doing product rule, it's easy to ignore this minus 2 sin x over here. We don't need product rule for this. So this takes care of our derivative for the first part. We need to also take the derivative of negative 2 sin x. Connor, what are we going to do whenever, what will we get when we take the derivative of negative 2 sin x? Good. Negative 2 cosine x. So I'm going to go back and label this just so everybody's very clear where everything's coming from. This part right here was our f. This part right here was our f prime. This part right here was our g prime. Right here was our g. And then this negative 2 cosine x over here, that just comes from the derivative of that extra part. It does not require the use of product rule. And so there's not really anything you can do with this. You could, you probably would just clean it up just a tiny bit. 3x cosine x. That 3 sin x is going to be written with the 3 out front. But that is really all that you can do to this. Right here, they'll probably just leave the answer like that. Okay, right here. Alright, so most of what you're going to see from your homework is going to be problems like number 1, 2, and 3. I do want you to use product rule on all problems, even if they are problems like number 2 where it could be done without the product rule. And the only reason that I want you to do that on this homework is just to get practice with product rule, right? After this homework, you're free to use whichever method you prefer. But I want us to practice product rule a little bit because you won't know if you like it better until you've tried it a few times. But 4 and 5 are a little bit different. 4 and 5, there might be 1 or 2 on your homework that are a little like this, but this is more like some of the stuff that shows up in free response questions. Particularly, you're going to see some stuff like this on the free response questions this week. And you'll also see this on multiple choice, like AP released questions too. Morning, Coach Wood. Have you found an error?
No. Just like my grades.
Uh-huh. So you separated 1 plus or minus 3. Is that double? That's IXL. Yeah. It should.
And they get so bad.
Yeah. Yeah. IXL can make you with a computer crossword. Yeah, because it should take both, but I guess they didn't program it that way. But we don't do fancy stuff like it. Divide both of those and get some
I mean, if it was, I would never make that 3 up 3.
Now, I would probably, because I would just like reduce all 3 of those and leave it with common denominator. I would probably do that.
You would leave it that way?
Yeah, just because I'm accustomed to doing it that way with, like, the other answers look like that if they don't reduce most of the time. So I would do it that way. I might put in that answer. But your answer's right, too. Okay. All right. Quick break. Now we're back. All right. So this tells us f of 3 equals 4. F prime of 3 equals negative 2. and g of x equals 3x squared times f of x, we need to find g prime of 3. All right, so we have to find the derivative of g, which is this function, but this function includes f, right? We got a composite function here, and we don't know what in the world f is, but we do have some information about values of f at 3, which is going to be helpful. So whenever we're looking at g of x equals 3x squared times f of x, this is one you definitely have to use product rule on because you've got 3x squared, which includes an x, times this mystery function that we don't really know that is just called f of x, right? So for this problem, when we do g prime of x, let's call, I don't want to call these f and g like I did on the last problems because they're using f and g here. I'm going to call this h, and we'll call this one f, since it is f, right? Just to have different letters since they called this one g right here. So the product rule tells us that we need to do h times f prime. So our h is 3x squared. Our derivative of f of x, we don't know anything to call it except for to just call it f prime of x, because we don't have the function for f. Plus f, which again we don't have an equation for, so we're just going to have to call it f of x, times the derivative of h. And Grace, what would the derivative of h be? 6x. Alright, so that would be our product rule. I'm going to go back and label these just so we're really clear on where everything came from. This right here was our h. This right here was our h prime. This right here, obviously, is f prime, since it's just called f prime. And this is our f. So, there's not really a lot we can do with that as far as simplifying. You can't really simplify it. But it did not ask us for g prime of x. It asked us for g prime of 3. So, to find g prime of 3, we are going to plug in 3's for all of the x's. So, we'll have 3 times 3 squared times f prime of 3 plus f of 3 times 6 times 3. All right here. Now, fortunately, they have given us the information that we need here because f prime of 3 is given right here. F prime of 3 equals -2. So we can put that right here. And they also gave us f of 3. F of 3 equals 4. So we can put that right here. So we would have 3 times 9 times -2 plus 4 times 18. And let's see, that's going to be 27 times -2, that's -54, plus 18 times 4 is going to be 72. And then that will give us 28. Do my math right there. You might want to double check me. I'm doing all 18. Yes. So g prime of 3 would be 18. They love to give these types of problems on the AP exam because you have to know how to do product rule, and there's no way around it if they give it to you with that f of x. Mm-hmm. You would only be able to find the equation at that point, yeah, because they have given you just the information for that point. So you could find the equation of tangent line at that point, but it wouldn't be the equation of f. Okay, questions? All right, let's do another one that's kind of theoretical here. I have f of x and g of x given to me in this graph. And the question tells me about this new function called h of x, which is 3 times f of x times g of x. And we are asked to find h prime of negative 1. So, to find h prime of negative 1, we've got to take the derivative of this function, and we've got an f of x times a g of x, so product rule is going to have to be used here. What do I do with that 3? We can just keep it out front, or you can put it with the 3, with the f, if you want. So it's up to you. You can either treat this as your first function and this as your second function, or you can just leave 3 out front of the whole thing and deal with it at the end. Either one is fine. I think I'm going to leave it all the way out front. Okay? So if I'm taking the derivative here, I'm going to do h prime of x, and I'm going to put the 3 out front, and I'm going to put me a bracket, because that 3 is going to have to be distributed to everything at the end. And so you're basically just writing down the product rule here, right? Because you're going to have f of x times g prime of x plus g of x times f prime of x. And you can distribute the 3 if you want, or you can just leave it out front. Either one is fine. Because now you are going to be finding h prime of 1, which will be 3 times f of 1. Oh, thank you. F of negative 1 times g prime of negative 1 plus g of negative 1 times f prime of negative 1. Now, I know that some of you dislike writing down both of those steps right there. On free response, I feel like we're the safest if we show h prime of x. We also show the next step where we plug in the negative 1 like this. Some of you may want to go ahead and start plugging in numbers, or you may never want to write this down with the x. I wish I had been an AP grader so I could tell you for sure how they would grade this. But no question, if you put both of these, then you're good, right? So I would rather be safer and put a little bit too much than be like, here's the bare minimum and I'm not going to do anything above it and then be wrong about it. So I'm going to require you to write both of these things before you start plugging stuff in when you have problems like these. And these problems show up a lot. So you need to show h prime of x, where it still has an x. Then you need to show h prime of negative 1, where you have these values. And then you can start plugging in numbers for these values. All right? So I want both of these things because there is a chance that the points that they give, they might give you a point for g prime of negative 1. So if you go ahead and plug in a number for that, but you haven't got it labeled anywhere, you might not get that point for that g prime of negative 1. So if we do it this way, we should be safe here. So we're going to have 3. And then for f of negative 1, we're going to look at the graph. F of negative 1 is right here. And what is the coordinate for that? Y coordinate? 3, right? So f of negative 1, we're just looking for the y coordinate from that graph because it's just the value. So that's going to be 3. Then we need g prime of negative 1. So on g, negative 1 is right here. But if we're looking for g prime, that's not the y coordinate. What is it? Slope. What's the slope of g at that point? Or really everywhere. It's 2, right? Positive 2. And they'll give you something that you can tell the slope from the graph. It'll either be a straight line or they'll draw a picture of the tangent line there where you can find it if you have a problem like this. All right, then we've got g of negative 1. This is just the y coordinate at x equals negative 1 on g. And so that's going to be negative 6. And then f prime of negative 1, that's not a y coordinate, f prime, derivatives are always slope of the tangent line, or in this particular case they are lines, so slope of the line. So what is our slope of f of x? It is going to be what? Negative 3. Technically, on for response question, you could stop there. This is pretty simple math. We're not going to. So 6 plus 18. So 6 plus 18 is going to give us 24. And 3 times 24 is the same as 6 times 12, so 72. No, would be our answer there. I'm thinking probably that the oopsies that Bo just said is probably a good case for stopping right here on the FRQ, right? Because even though this is pretty simple and we should be able to do it, it is common for us to make mistakes as high level of mathematicians as we're dealing with here. I mean, you guys are the elite. Not everyone makes it here. We still make some mistakes pretty often. I messed up on the last one and had 28 instead of 18. So it is perfectly fine on FRQs to stop here. But you also need to be able to simplify it because not all of the questions are FRQs. All right. So here's your assignment. You've got, oh good, we've got some time to work on it. And let's see. Okay, these should be pretty straightforward for these. 1 through 6 is just asking you to take a derivative. 13, 17, 19, those ask you to take a derivative at a specific point, so you'll be plugging a number into them. 69 and 70 ask you for an equation of a tangent line, so you're doing the whole thing there. So go ahead and get started on those.